Hello, we are from Group 8 and for this assignment we did question number 8. In this question, we are asked to determine the heat transfer coefficient, the temperature of the outer surface of the rib, the amount of heat transferred to the rib, and the time taken for it to be medium cooked. The assumptions for this question is that the rib is homogeneous spherical object, one-dimensional heat conduction, thermal properties are constant, and finally the heat transfer coefficient is constant and uniform. For part A, we are first finding the Fourier's number. To find the Fourier number, we have to find the radius first. And to find the radius, we are using this equation, m equals to PV, and then we'll get the V equals to 0.002677 meter cube. And then since volume equals to 4 over 3 pi r cube, we can calculate the radius, which is 0.8603 meters. And then we can substitute the value of the radius in this equation and we will get the tau equals to 0.1217. Next, we can substitute these equations into this equation to get the value of A and lambda. Then referring from table 4.2, we will get the BI, which is the Bayer number, equals to 30. Since we have the Bayer number, we can substitute that into the Bayer formula, which is BI equal to H radius over K. And finally, we will get the heat transfer coefficient to be 156.9. For part B, we are supposed to find the temperature at the surface of the rib. Since we know that the temperatures and the value of A, lambda, tau, and radius, we can calculate to find directly the temperature of the surface, which is at 159.48 degrees Celsius, and to convert this to Kelvin, we add 273. Then we will get the final temperature at the surface of the rib to be 432.48 Kelvin.
For part C, we want to find the amount of heat transferred to the rib. But first, we will find the Q maximum. That can be by using this equation, mCp T ambient minus T initial. We substitute all the information given and we will get the Q maximum as 2080 kJ. Then, the actual amount of heat transfer can be determined by Q over Q max is equal to 1 minus 3 theta sine lambda minus lambda cos lambda over lambda cube. We substitute all the value that we've obtained and we will get 0.783. And finally, we obtain the Q as Q that need to be transferred to the rim as 1629 kJ. Finally, we need to find the time taken for it to be medium cooked. We can use this formula. Theta is equal to T naught minus T ambient over T initial minus T ambient equal to A ln negative lambda squared tau. All the values are all given and we need to find the tau, which is 0.1336. After that, we can substitute it into equation tau r squared over alpha, which is also all the values are given, and we will get 181 minute, convert to hours, we will get 3 hours. The result is close to the listed value of 3 hours and 20 minutes. The difference between the two results is due to the Fourier number being less than 0.2, and then and thus the error in the one-term approximation. The temperature of the outer parts of the rib is greater than that of the inner parts of the rib after it is taken out of the oven. Therefore, there will be a heat transfer from outer parts of the rib to the inner parts as a result of this temperature difference. The recommendation is logical. Thanks for watching.